Hello friends, this is Neil Shukla here from School International. I am welcoming you to yet another session regarding HVAC and its importance in offshore sector. Before starting the lecture or before starting the session, I wish and I hope that you are all well in good health and high spirit. Yes, let's learn to this new, more exciting and fascinating chapter for the HVAC for the marine offshore sector. Basically, what I'm going to talk about it is when HVAC, we all know that we are important everywhere, that is building, commercial, everywhere. But when it comes to offshore, our role changes drastically. And all I'm going to talk about is our change role only. How we have been seen by the people in offshore industry. What is our role in offshore industry? Yes, we get handsomely paid. That's a different matter. But we as a consultant also we get handsomely paid. But it's not an issue of the pay only. It's about working together as a team, how we work together, how we see each other, what are the inputs we need from other disciplines. This is what this session is all about, and how to handle and tackle it very, very effectively. So let's begin this session one by one. As we explore more into this session, you will understand what I mean to say about the importance of HVAC. Some of the terminologies may be new to you, so I suggest that before watching this video, you complete our one more session which I've already covered previously. In that I've given all the terminologies in that particular session. So you will find it a bit easy to understand it. Nevertheless, I'm going to talk in simple language, so anyway you will understand what I'm trying to say. So just stay tuned and focus on what I'm trying to say in the upcoming slides. Here the learning objectives is mainly we HVAC engineers are nothing but the backstreet boys of the offshore oil and gas. Yes, offshore oil and gas is mainly about a processes, or it has a lot to do with a structure, process, and recovery of oil and distribution of oil. But one thing is always we need to keep in mind that wherever there is a structure and the structure, suppose there is any room, HVAC is mandatory. You cannot avoid HVAC if you are going to construct a room for any purpose. Even if you are going to construct a room to keep an equipment, even if you are going to keep the room for a person should go and work, even if you are keeping the room for people to stay, or even purpose of the temporary refuge. In any of the situation, wherever there is an enclosed room, wherever there is a steel structure for a room with a door, HVAC or air conditioning, even if anyone wants to avoid, he cannot avoid. Because when the HVAC comes, whole lot of things come into this. That is electrical come into this, instrumentation come into this, space requirement, then your weight requirement, everything comes into picture. But if it is required, if it is required. So that's why, we have been treated, it's like a necessary evil. In offshore industry, HVAC cannot be avoided. But at the same time, they hate HVAC. Okay, that's a very funny equation. Why they hate? I will tell you in subsequent session. It's very, very funny session. You will like it. That's why I want to make it more and more interactive and in a funny way. You have all these things, these Backstreet Boys. This is a very famous band, and now it's not long back. At my college days. Okay. And their song is there. Who we are, what we do. It's not like who you are, what you do, where you go, as long as you love me. That was a very, very romantic song of this particular Backstreet Boys. You can Google it out if you're not aware of it. And this song is like that only. For HVAC guys, we are always seen as who we are, what we do, where we do. So I'm going to cover it in the subsequent slides. So just stay tuned. This is going to be very, very funny session. Now let's move on to the next slide. This is how we have been perceived. In a commercial and residential sector, as you know, we are always seen as a team, or without which they cannot go ahead. Suppose in the Gulf, you are doing executing a project. then they, as you know, for human habitat to survive, the air conditioning is must. So anyway, they have to go with the central plants to serve the building. So without us, no building is complete in the Gulf, especially. So similar way, if you go to shopping mall also in India nowadays, it has to be air conditioned. So this is all we in India or we anywhere in the world we go, we deserve that kind of a respect nowadays than the earlier one, because the scope is also going up and altogether market is becoming open. It's going to be a different ball game. So in the residential commercial sector, we are like a Captain America. Okay, we in the invincible. Nobody can avoid us, and everyone needs us. So in the bad situation, suppose the temperature, they will call us. Okay, AC guy, send the AC guy. We are getting and fixing the issue. So this is what we have. We deserve a respect in the field of the building and commercial and residential sector. But when it comes to the offshore sector, oil and gas sector, we are aliens. Because we have always seen, okay, what these guys are doing HVAC over here, because this field is more often process and chemicals and stuff like that. And what's the need of an HVAC guys over here? So this is what we have been seeing, and we enjoy that attention also because people see us in different angle. So, but I will tell you why the HVAC is needed. HVAC is one of the only disciplines. You'll be surprised to know that HVAC is perhaps the only discipline in the entire offshore industry that can be perceived. You can feel the temperature. By human attending. You can feel that no ventilation is there, and without us, they cannot survive. They cannot work, right? Other disciplines like structure, it is all static department. Piping is a static department. So instrument can't see the signals. Electrical, we can't feel the current. Okay, unless you go and touch. Okay, so these are few things. Again, process. We can't see the process because it's happening inside the equipment. But here, it can be perceived. You can feel it. You can feel the cold. You can feel the hot. So this is how we can be felt. Okay, so this is very this chapter or this particular thing becomes very exciting at sometimes. Now here in this particular session, I'm going to talk about the interdiscipline interface with the HVAC. What do I mean by interdiscipline HVAC interface? Is that when any oil and gas offshore platform we work in those platforms, we need to mainly uh, work with these disciplines. The HVAC discipline with these interfaces are mandatory. There is the process discipline in offshore oil and gas, electrical discipline, instrument discipline, then technical safety, technical health safety discipline. Then loss prevention is the same name for that department. That is THSC we call normally. That is technical safety, health and environment. Then structural discipline is there, architectural discipline is there, piping discipline is there. Discipline is nothing but a department. So in engineering firm we call it as a discipline to the other name of a department. So it's a common terminology over here. So when someone asks you which discipline you are from, so don't get confused. You should always knowing that HVAC is a sub branch of a mechanical department. So we have been always put under the mechanical section. So you can always say, okay, I'm from mechanical discipline. So they understand that what kind of roles and responsibility you play in offshore oil and gas industry. Or suppose you get an interview call from the company in the oil and gas sector. Then what you need to do simply is just go to the LinkedIn and check for the head of the department mechanical of that company, and you may come up across the profiles of that company, and from that you can imagine the kind of a person who is going to take you the interview, and that might be mostly one of the important person who is going to decide whether selection or your selection or not is going to be the head of the mechanical department or head of the piping department. So just analyze his profile correctly, what kind of person he is. So prepare yourself the interview for that. So this is just all about to keeping yourself aware that how to approach interviewer, how to reach out to the proper person. because you cannot simply send a CV to HR, because HR is only a coordination department. So you need to hit a right button over there. So process discipline plays a very, very vital and important role in offshore oil and gas. All I can say is more than 50% role in of entire offshore oil and gas is of the process discipline. Yes, process discipline are mainly chemical engineers, most of them, and their role is to define the processes mainly for the offshore oil and gas sector. And the processes comes under the various from how to extract the oil, how to separate the oil, mud separator, oil separator, gas separator, all these things equipment. Their majority of the role is to prepare the P and IDs, that is piping and instrument diagram. How the pipe will go, how the equipment will be there, how the separation will happen, how it will go straight, and what kind of instruments normally would be required and stuff like that. So they play a very, very important role. Though instrumentation department also goes hand in hand, but I will tell you about it later on. So since every discipline has an interface with other discipline, so this way or the other way. Okay. So the main purpose is to understand each other. So this is I put it from the perspective of HVAC, that what we need from the other discipline and what other discipline need from us and why it is needed. Similarly, from the other discipline also, they have an interfaces with each other. Like piping has an interface with process and instrument. Instrument has an interface with again the electrical, piping and process. So this is all about the interlocked. Everything is interlocked. This project is all interlocked with each other. So again, the electrical department, no need to say, the equipment which are installed on the platform needs, of course, the electricity and how to generate it, how to distribute it to the equipment, earthing of the same. So this is all been handled with the electrical discipline. The instrument discipline role is, of course, to install the instruments at the proper places and to check the parameters and give the signal to the controls and stuff like that, and to basically the monitor the whole system whether it is working as per the set parameter or the design parameter or not. The then THSC and loss prevention also plays very, very important role. They are basically, they define the safety, how safe whatever we are design are they meeting the offshore platform requirement. Okay, there are a lot of standards are been set, and this is mainly a theoretical game they play over here. A lot of theoretical knowledge it has involved, and they have to check with the various standards, and then they need to establish the requirement. And while they establish the requirement, they need to be very, very particular about it while establishing the requirement, and about the safety, like escape routes. And they have to always think that in worst case scenario, how the things should be planned. In worst case scenario, what will happen? In worst case scenario, how should I plan the escape routes? So this is what they will all think about and go about it. So when I say about the technical safety, their role comes into the helicopter landing, how it will happen, space required around it, and escape ways, and the equipment, whether they are located in hazardous area or not. So this is what they all have to think about it. Then you have structural discipline, all how to stabilize the platform, how to check the center of gravity of everything, and how to provide props, and how to provide the supports to the pipes and all. This all falls under the requirement of the structural discipline. That is a very, very complicated discipline. Sometimes they have to work to assess the condition of the existing platforms. So suppose a platform is there 30, 35-year old. So all drawings are given to them and they have been told to check, go to the existing site and check whether this kind of platforms are good enough to take the load or not. Then let us go to the next, that is architectural discipline. Architectural discipline also plays very, very important role over here. Architectural discipline is when your structure or room is being designed. Suppose a person accommodation is there, living platform is there where people are going to stay. then doors, showers, windows, panels, beds, then laundry arrangements and kitchen arrangements, all to make a space livable or make a place functional. That is the role of the architectural discipline. And HVAC again has to play an important role here with architectural discipline. How, I will tell you later on. But again, the piping discipline also comes into picture, and role of piping discipline, particularly with HVAC, okay, also plays very important role. Of course, they will not take care of the chilled water piping. They will not take care of the drain water piping. They will not take care of the copper piping also. So you will ask, they are piping discipline, then why they are not helping in HVAC discipline? The answer is simple. When the HVAC is there, we are the subject matter expert. So we have to handle it because they have to handle a lot more things in offshore sector. So let them handle. So this is all about the discipline introduction I've given to you. These are the major disciplines for the offshore oil and gas. There are some minor disciplines which we are not going to look into it because they play very less role over here. Yes, every discipline is important, but they do not play the significant role and do not have the much interaction as with the HVAC. So let's go to the next slide. Now let's look at the interdisciplined interface with the HVAC process. As I told you, the process plays very important role in offshore oil and gas sector. But when it comes to the interfaces or to handling the interface, here is the major difference over here. Uh, yes, the process also has an interface with HVAC, and it happens in terms of providing the water to our water cooled chillers or to the air or pneumatic air to our pneumatic dampers. So as you know, for HVAC discipline, we need to install the fire dampers or we need to install the other dampers also. So for those dampers, it is recommended those it is not it is mandatory to provide these dampers as either pneumatic operated or electrical operated. The reason what I say pneumatic operated or electrical operated is very simple, because when you go to oil and offshore oil and gas, you have to automate most of the things. You cannot simply go and because the changeover happens like duty standby unit. I'm going to teach you in the next sessions why the duty standby units or duty standby HUs are required, or why the duty standby motor configuration is required for offshore oil and gas. But when you have to change over from one HU to another HU or from one fan to another fan, you need to provide these dampers. Plus again, in case of fire situation, you need to shut down the damper. It has to be either electrical or it has to be a pneumatic. So wherever pneumatic dampers you are providing, you need to have an air, a compressed air. And again, a compressed air is a job of the instrumentation discipline. So to provide that compressed air to us at a particular location and time, then further it has to be carried out to the other places. So this is how the HVAC and process discipline works hand in hand. So they have to provide us an instrument air to connect it to our fire dampers. Then seawater quantity is also needed for the condensers. See, all we know that we have a requirement of installation of chillers. So when it comes to chillers, or suppose we install a chiller of particular capacity, in that case, what happens is your overall requirement of water over here is they don't provide you a fresh water. What they provide you is a seawater that is once through, that is water comes in and it goes out and goes back to the sea. So this is what the arrangement happens in case of the seawater requirement. So a seawater condenser, the condensers has to be again a seawater condensers. So to have a seawater condensers over here, again it's a different metallurgy, but again when you go for the seawater condensers, again you need to consider the loss in cooling capacity over here because the material difference is there. So here when it comes to process discipline, you need to be careful that when you start a project, use the thumb rule because they have to size their pumps. So tell them that okay, this is what the water quantity or seawater quantity you need for this project. So they plan because for them it is not only HVAC, they have to serve various other disciplines also, where they need seawater for cooling and all. We call it the raw water in the offshore terminology. So they need to calculate that. So we need to tell them that what we need, that is seawater quantity needed for the condensers, is what we need to give it to them for them to design the overall system or overall plan for the seawater pumping system. Then instrument air requirement, we need to give it to them how much is required, what pressure is required. And seawater temperature is something we need from them. Okay. Suppose we need this much quantity, this much temperature, the water is coming in, so we can design or select the plant accordingly. So this is what the process and importance plays role over here for the process discipline. So let's move on to the next slide over here. That is interdiscipline interface with HVAC and instrument. How HVAC and instrument discipline are related to each other, we are going to talk in this slide. It is IO summary is there, it is fire and gas philosophy is there, fire smoke detector location, then fire and gas dampers has to be hardwired with the fire and gas panel. Yes. See, here in offshore oil and gas sector, you cannot directly connect your fire dampers to your HVAC control panel. No, it has to hardwire to the fire and gas panel, which is the scope of an instrumentation discipline. That is for the utmost safety requirement. So any fire detected or any gas detected on offshore oil and gas platform, first the signal comes into fire and gas marshalling panel. And from fire and gas marshalling panel, these all fire dampers are hardwired and they immediately get shut off, irrespective, any status comes of detection of fire, detection of gas, they immediately shut down the fire and gas damper. And the system either technical safety may determine whether the HVAC system has to go in the shutdown mode or it has to go into the recirculation mode. This is all they take the call. But this is very interesting aspect we'll talk about later. But you need to understand that why the instrumentation discipline is important, because the fire and gas dampers, connection of fire and gas dampers happens into their panel. There is fire and gas panel. And fire and gas panel comes under the instrument scope, department scope. The fire and gas smoke detectors also play a very important role as far as HVAC. As you know, suppose any fire and gas activity happens, it has an impact on HVAC because we have fresh air intakes provided, and it should not happen that way that we are sucking the gas. So gas distress happens there. So we need to check the interface of that and speak with the technical safety department that whether the HVAC has to be shut down or not. FNG philosophy plays very important role because it has a cause and effect diagram we need to prepare. What is the cause and what is the effect of that? Suppose the cause is fire, then what will happen the effect on HVAC? Suppose fire is internal or external, what will be the effect on HVAC? Suppose fire is happening within the kitchen, then what is the impact on HVAC? So whether HVAC should be running or it should be recirculation mode, what effect it will have on HVAC, this is what the fire and gas philosophy, it falls under Department of Instrumentation. The IO summary, as you know, no need to explain your HVAC engineer, input output summary of signals. This also we need to give it to them sometimes, and they help us in deciding the control panel. So let's move on to the next slide. Interdiscipline interface with the electrical discipline also plays very important role here. The reason what I say is that, as you know, without electrical, HVAC cannot move because we need power to run our equipment, and to run that or to run the equipment, of course their role plays their involvement is required. So we are incomplete without each other, in fact. So when we reach to the electrical discipline, we always ask about the voltage and the frequency available on the platform. as you know that if you don't know the voltage or frequency, you cannot just select the unit, because voltage and frequency is most of the 99% of the time it's 50 hertz in offshore oil and gas. But you cannot assume the things in offshore oil and gas. You need to be always alert. So you need to always check in the case that, for example, you have to select the chiller, or you have to select a fan, or even you have to select the condensing unit, or you have to select the AHU. Your motor has to be either 50 hertz or 60 hertz, right? So when you go for that, you need to always ensure that suppose a motor is 50 hertz or 60 hertz, from the catalog you need to select the motor for that particular hertz only. You can simply follow the catalog and what is written here. You need to check that the speed or RPM or the airflow which is given, that is for the how many hertz. So unless we know the frequency, we cannot select the equipment in a correct way. Or we should not select the equipment at all. So electrical discipline is very, very major input we need is what is the frequency that we need to ask them. Next important thing is the heat dissipation value. Heat dissipation value of the equipment is nothing but how much heat is being dissipated. No, you are an HVAC engineer, so you know what I mean by heat dissipation, and it's important in designing or doing the heat load calculations, right? So this is nothing but a sensible load or latent load. You know the HVAC engineers, you know the answers, right? Give me the answer. Heat dissipation from electrical panel is sensible load or latent load? It's a sensible load, right? So it plays very, very important role while selecting the AHU, because AHU airflow capacity is directly proportional to your sensible heat. It's all about sensible heat. So your AHU capacity, AHU sizing is all going to get decided based on your sensible heat over here. So here HVAC heat dissipation also they need to give it to us, or if they don't give, we have to assume with certain things. Then let's go to the HVAC electrical load. Here the electrical load is something which input we need to give it to them. What I mean we need to give it to them is we need to tell them that how much load is connected, or how much what is the motor sizing for particular equipment. For motor sizing for AHU, this much 5 kilowatt, 6 kilowatt, chiller is suppose 100 kilowatt or whatever. That we need to inform to the electrical department. So they help us designing the HVAC control panel, the size of HVAC control panel, starters and stuff like that. All they take care, and the cabling respective to the HVAC equipment from the control panel, all they take care. What is the incomer size they need? Suppose you say that you have control panel with so many connected loads, so they have to calculate the capacity and they need to put a control cable, or they need to provide the power cable, not control cable. Control cable falls under instrumentation discipline, so they need to give the power cable. So that also is required. So let's move on to the next one. Is electrical panel specification plays very important role over here, because in offshore industry, I will discuss later, it is form 1, form 2, form 3, form 4. There are various things into the picture. So this is also very important input. They need to give it to us, or we need to give them as per the standards. Then duty standby configuration, we need to inform that offshore sector there's a duty, there's a standby, working standby configuration, which equipment has, which equipment doesn't have. So they plan the HVAC control panel accordingly. Then the requirement of the isolators for the maintenance purpose also we need to inform them. Suppose there's a chiller, or suppose there's a pump, there's a fan, then you need to isolate the fan or the pump for the maintenance purposes. This is what the requirement is also mandatory. Then the requirement is there for the damper voltage. The damper voltage also plays very, very important role over here. So again, it's quite deep, so I will explain it in the next sessions. So then again, the shutdown philosophy. Suppose a fire happens or gas happens, then they need to cut down the electrical power. So again, the interface comes into which discipline or which equipment needs electrical power, which doesn't need. That we all force it together. HVAC, electrical, instrumentation, and technical safety. We need to force it together and decide, discuss and decide it. Normal and emergency load distribution also play a very, very important case of fire. Which are the discipline which needs power to run the things? So that falls under the emergency. So according to that, they calculate the diesel generator load. So this is what the interface with electrical comes into picture. The discipline interface with the HVAC and architecture is also very, very interesting over here. Here they play a significant role. Again, the HVAC and electrical, as you know, that the relation is like a husband and wife. Same role architectural plays in the building sector also. Same way we have to fight here with them also. They always need height. We need to run our duct, so we always say lower your fall ceiling. So this is all the games we have to play here also to get our right, because they want beauty, they want everything, that is fine, but beauty is incomplete without duty, right? So unless you serve the duty, the beauty has no meaning. Unless HVAC is there, no room of people just staying and sitting on the bed. They should feel comfortable also, not only but just by means of the nice pillow, but at the same time with nice environment and the comfortable temperature also. So there again the HVAC room sizes, plant sizes, shower, riser locations, the room ceiling heights, then galley laundry heat dissipation also they have to provide, because it falls under their scope most of the times, because they are designing the laundry and the galley. And the freezer room details also falls under architectural, so they need to provide the inputs that at what temperature everything is coming in, going out. Then room layouts also, when they need to tell us the space for the maintenance provision and material handling also, we need to give it to them so they can plan their alleyways to keep the provision for the material to move around. So this is also same way we have to fight as the in the other project also. Same way in the building sector also we need to fight with the architectural discipline for the same purposes. Then interdiscipline interface with HVAC and technical safety also very, very important. Here the cause and effect philosophy is there, black start is there, smoke management is there, fire and blast rating of the bulkhead is also very, very important, hazardous area classification zone, temporary refuge philosophy, and hazard workshops and other safety workshops. These are all the things which is related to the technical safety. As I explained to you earlier, the technical safety plays very, very important role because it has to check all the worst case scenarios in case of something worst happens for the platform. It may be it may be oil leakage, it may be a gas leakage, it may be a fire alarm, it may be a smoke alarm, it may be a gas alarm. So in that case, how the people or how the systems or how the process has to be protected, at the same time how the people who are working on the platform or personnel who are working on the platform has to be safely evacuated, or they have to be very, very safe. So for that, what needs to be done is all about the technical safety discipline role, or how they can be evacuated by means of ship, or suppose there's a ship which is coming to deliver the food to us, then how safe it can be landed, the boat landing, all these aspects, structural discipline and all the interfaces and all, the technical safety plays very, very vital role over here. They are one of the backbones of the offshore oil and gas. So they are completely important over here. So I will again discuss in deep what is black start, what is smoke management, and what is hazardous area classification, because this is just a basic introduction, so I'm just keeping it short and simple. So, but anyway, I'm going to cover it in the next session. Why the technical safety plays very important role, and what is the meaning of these terminologies. Because each terminology is so deep that I can talk about each terminology for the 3 days in non-stop. So let us focus in why the other discipline are important in HVAC. Again, discipline interface with structural and piping here. The structural, we need to give the equipment weights to them, foundation, external pipe, duct support, beam height, penetration details. So this is what we need to deal with the structural discipline. because we have equipment foundation, so we need to give them the weight to design the foundation. In offshore sector, there is no concrete use, so it is a steel structure, steel frame. It is properly welded to the deck, and you have to provide a foundation. You have to provide external pipe and a duct support, and you need to have a beam height and penetration details. Then beam height is nothing but you have a ceiling and you have beams, concrete beams. Similarly, the beams are here also, but they are not concrete beams. They are the structural beams, that is, the steel beams. And so the steel beams, you cannot penetrate the steel beams. You need to go below. Okay, penetration strictly avoided over here. So you have a steel. You have to have the beam heights. You need to decide penetration details. You need to decide. So there's a lot more interface again with the structural discipline. Also plays very important role. Then there comes the piping or a plot plan or 3D modeling. The piping plot plan also plays very important role over here, because piping discipline prepares the plot plans basically. And when they prepare the plot plan, we get the room sizes and everything over here. So and the 3D modeling also they play important role over here, because the 3D modeling, they show they use the Aviva software, and they do the 3D modeling, internal room layouts and all. They just plot our equipment inside and show the piping and check for the clashes. So lot more important activities happen here also. So these are very basic information that I'm giving to you for the interdiscipline interface with various disciplines. So this gives an idea, and as you know that in offshore oil and gas sector, the process, structural, piping, electrical instrument, HVAC, technical safety, mechanical, even though they are different, but we are one team. So when we come together, we become a team and we become stronger. So we have to all whenever we work in a company, we need to make sure that we as a team should come together and work together. Then only we become stronger. Then only we become a true professional. So this is what I want to explain you, that together we are one, and no discipline is stronger or no discipline is poorer or no discipline is less important. All disciplines are equally important if we work together and each understand each other as a team, because each of the finger has an important role to play. So it is not that only thumb is important or other index finger is important. Every finger is important.